In this video, we'll talk about classifying polynomials, especially classifying polynomials by their degree. We talked about in class how to classify a polynomial by the number of terms that it has, monomial, binomial, trinomial, so on and so forth. But we didn't really get a chance to talk about identifying by the degree of the polynomial. So what I would do right now is is pause the video and try this problem out. This is the one for the warm-up for today. Identify the degree of the polynomial, then identify the name of the polynomial by its number of terms, then identify the name of the polynomial by its degree. The first one, x squared minus 2x to the fourth plus 7, 9 minus x, 22x squared plus 3x minus 4, and 5. Now, we can make a chart like this. This is everything that we're asked for. We're asked for the degree, classification by the number of terms, and classification by degree. So let me fill in this chart. The degree of this one is 4. It's not in standard form. Remember that if you're given something that's not in standard form, it might be a good idea to start by putting it into standard form before you even start anything else. Degree is 4. The largest exponent is 4 right here. The degree of this one is 1. Remember that we have an implied 1 right here in our exponent. And we're talking only about the power on the variable. We're not talking about the power of our constant term or anything like that, but the power of the variable term. And the degree of this next one is 2, and the degree of this one is 0. Again, we have, this is 5 to the first power. However, we're not looking for the power on the 5, we're looking for the power on the x. The power on the x is 0, and this determines the degree. It's the highest power, or the sum of the highest sum of the powers. So classification by terms. This one we would call a trinomial. It has 3 terms, x squared, negative 2, x to the fourth, and 7. This one we would call a binomial. We have a constant term right here, and we have this x to the first power. So that's a binomial. This is another trinomial. Oops, trinomial. And then this one is a monomial. It only has one number. And I'm going to erase these because they're not actually necessary, and we're going to try and get by without actually writing anything that's unnecessary. Now, this classification by degree. Let's go through some examples. So let's start with something with degree 0. An example of that might be just plain old 22. That classification, that's just a constant, so we're just going to call that a constant term, a constant polynomial. If we have something with degree of 1, that looks something like this. Negative 3x plus 4. Negative 3x plus 4 is, if we have y equals negative 3x plus 4, we would have a linear function. That would make a line if we graphed it. So this is a linear polynomial. And 2, it's getting all funky. If we have a degree of 2, that looks something like this. X squared minus 45x plus 3. That is a quadratic. And most of what we're going to be dealing with in the next couple units are quadratics. Not all of them, but quite a bit. And then something with a third power is called a cubic equation. That might be something like x to the third minus 2x plus 14. We could also have something that looks like it doesn't all have to be just x's. Anything with a degree of 3 is going to be considered a cubic equation. So if I had xy squared plus 4, remember that the implied power on this x is going to be a 1 right here. And if I add these two, that'll be a 3. So this has a degree of 3, therefore it's called a cubic. Most people that you talk to probably wouldn't call it a cubic. They would probably say a polynomial with degree 3, but technically it is a cubic. Most people, when they say cubic, though, they think of a univariate cubic, so just one variable. And if we have a degree of 4, we call that a quartic. Careful not to confuse that with quadratic. Quadratic is degree of 2, quartic is degree of 4. So something that looks like this. X to the 3x to the 4th minus 7x plus 7x. That would be a quartic equation. And then we might have a 5th degree, which is a quintic. And we might have something that looks like this, just plain old x to the 5th. Or we could have something, oops, having a little bit of trouble with my computer. X squared times y to the 3rd power. 2 and 3 add up to 5, therefore this has degree 5, therefore technically it is a quintic. If we go back up here to these polynomials, I don't really need to look at the polynomial anymore. All I'm interested in is the degree. The degree is 4 on this one, so this is a quartic. The degree is 1, so this is linear. The degree is 2, therefore it is quadratic. And the degree here is 0, so this is a constant polynomial.